Welcome to Lecture 12, Systems Planning and Development. And in this lecture, we'll explain the importance of the steps in IT planning, describe the systems development life cycle, explain the challenges involved in systems development, and list the advantages and disadvantages of different system conversion strategies. We'll also take a look at agile system development methodology and when it should be applied and in what circumstances it should not. We'll explain the concept of systems integration and finish up with a look at the being able to contribute a meaningful set of requirements when serving on a project development team. Enterprise information systems are gaining in popularity. Information resource investment considerations include the fact that an information system requires a substantial investment and can carry a high risk in implementation. Successful integration of the system is vital. So we must align IT strategies with the overall organizational strategies. A careful planning of an IS implementation is necessary. And here we see the key steps in IT planning. A mission statement, a vision, strategic and tactical plans, operational plans, and then a budget that ensures the resources are available to achieve the mission and the vision. And here's a graphic of the steps that we just enumerated. And we'll go into them in more detail right now, in fact. The mission statement communicates the most important overarching goal of the organization and includes the goals and how they will be achieved. The IT mission statement describes the role of IT in the organization. The mission statement should be compatible with the organizational mission statement, and it should include the ideal combination of hardware, software, and networking to support the mission. The CIO develops a strategic plan for implementation of information technology in the organization. That plan addresses what technology will be used by employees, customers, and suppliers. Goals in the plan are broken down into objectives, such as resources to be acquired or developed, timetables for acquiring and implementing resources, and training. Objectives are broken down to operational details. IT planning is similar to the planning of other resource acquisitions. A growing proportion of IT funds is spent on software in the early years. More purchasing and adapting of software is happening, and less developing in-house of software is occurring today. Here we can see how IT planning can be driven by a variety of sources in the marketplace. So, the benefits of standardization in planning. One major goal and advantage of planning is standardization. And of course, we went over the planning process. Some of the benefits of standardization in that planning process are cost savings. You have better bargaining power in purchasing and leasing hardware and software. Efficiency in training. A smaller variety of software reduces employee training needs. And efficient support enables more staff specialization. From planning to development. After planning, management must decide how to obtain the systems, and that's usually going to involve software. Approaches to systems development are the same for in-house or purchased systems. There's two general approaches. The Systems Development Lifecycle, or SDLC, that's the traditional approach, and non-traditional methods, including agile methods. Prototyping is a fast development of an application based on initial user requirements. The two development approaches are not necessarily mutually exclusive. Systems development may involve progressive elaboration. As more information and knowledge is available, a vision of an initiative will continually develop, and that progression influences the final product. So, what is the systems development life cycle? Large information systems are conceived, planned, and developed within the Systems Development Lifecycle (SDLC) framework. This is also known as waterfall development. The major sequential phases of SDLC include analysis, design, implementation, and support. And here we see the phases in the systems development life cycle. Analysis, systems analysis, is a five-step process. First, there's an investigation, then a technical feasibility study, then an economic feasibility study, an operational feasibility study, and requirements definition. And we see the phases and systems analysis here. And obviously, after each feasibility study, a go, no-go decision will be made. So investigation is where we check, is the system really necessary? Is the system as it is currently conceived even feasible? A small ad hoc team performs a preliminary investigation by interviewing employees. Feasibility studies are a larger analysis that's conducted after preliminary results indicate an information system is warranted. Technical feasibility study determines if the components exist or if they can be developed, and also determines if the organization has adequate hardware and infrastructure. An economic feasibility study is a cost-benefit analysis that shows the costs and benefits of the proposed system. A return on investment is calculated, and that's the difference between the stream of benefits and the stream of costs over the life of the system. Operational costs during the system's life include software license fees, maintenance personnel, telecommunications, power, and computer-related supplies. The total cost of ownership, TCO, is a financial estimate for business leaders to objectively and accurately evaluate the direct and indirect cost of a new organizational project. And here we see an example spreadsheet that estimates the cost and benefits of an information system and gives a net present value based on a 6-year analysis life. Operational feasibility studies determine how the new system will be used. The organizational culture is the general tone of the corporate environment, and the analyst must determine the new system's compatibility with the organization culture. Systems requirements detail the functions and features that are expected from the new system. Design. This is the second phase in systems development. Systems design includes 3 steps for devising the means to meet all the requirements. First, description of the components. Second, construction. Third, testing. If purchasing a system, the design phase determines how to adapt the existing software. Construction is actual changes in program code. Here we see the phases in systems design. You describe components, you construct them, and then you test them. Symbols are used to communicate ideas about data, processes, and information. Visual information can be grasped more quickly. A data flow diagram describes the flow of data in a business operation using 4 symbols. External entities, individuals and groups external to the system, and these could be customers or employees, processes, an event or events that affect data, data store, any form of data at rest, and direction of data flow, which indicates how the data moves. And here we see some of the notations that might be used. Obviously there's different sets of notations, but this one is fairly standard. And we see symbols for entity, process, data store, and flow of data. The simplicity of a data flow diagram is its main advantage. Data flow symbols are suitable for describing any information system, including non-computer-based information systems. They can be used to help pinpoint weaknesses, where processes can be automated, what is shared by different processes, and what can be changed to strengthen the IS. A data flow diagram cannot describe a system completely. It does not depict computations within processes or timing relationships among data flows. And here's an example of a data flow diagram. Entities deal with processes, and processes may retrieve or store data in our data stores. Unified modeling language is another standard for visualizing, specifying, and documenting software. It helps developers communicate and logically validate desired features. It's independent of programming languages, and it provides standard symbols and notations for depicting object-oriented elements. UML consists of diagrams, a use case, and that's an activity of the system in response to the user or an actor. A class describes the class structure and contents. Interaction describes interactions of objects and the sequence of their activities. And state charts indicate the states through which the objects pass and their responses to stimuli. In a uniform modeling language diagram, an activity represents a highly active state triggered by the completion of other actions. Physical diagrams are high-level descriptions of software modules. And here we see a unified modeling language, UML diagram. And we have actors, order clerks, for example, that have certain use cases that they need to do, and then those use cases will in turn result in change in the state of a particular object, and we have a class diagram for the various objects that might be instantiated to perform a particular use case. Construction consists of mostly programming activities and may take months or years. Each completed module is tested, and then the modules are integrated. System testing is the test of the entire integrated system, comparing results to the system requirements. The testing period often is compressed due to schedule or budget issues, and that results in poor testing, and that can result in a system that has bugs after it's been implemented. Implementation is the delivery of a new system. The steps include conversion and training. Training may or may not precede conversion. Conversion is the switching from the old system to the new system. And this can be a very difficult time in the organization. Some of the conversion strategies for implementation include parallel conversion. The old system is used simultaneously with the new system, at least for a while. Phased conversion breaks the new system into modules and integrates them one at a time. This reduces risk, but it delays some benefits. And then a cutover conversion, that's also known as a flash cut conversion, immediately replaces all modules. That is risky, but may be the least expensive approach. Another conversion strategy is a pilot conversion, and that introduces the information system into one business unit at a time. A beta site is a site that tests the new system. And here we see a graphic of the 4 types of conversion strategies: a parallel, phased, cutover, and pilot, and how you get to the new system from the old system over time. Application systems support. This includes 2 responsibilities: maintenance, which is post-implementation debugging, updates, and adding postponed features, and user help. Maintenance comprises up to 80% of IS budgets. Support is the longest phase of the system lifecycle. Effective maintenance requires good system documentation during development. Agile methods are an alternative development methodology. It treats software development as a series of contacts with users. The goal is fast software development, and you can improve software after user requests for modifications are received. Agile methods use iterative programming. You get an initial set of requirements, put out a system, get change requests to that, and update the system, and you keep doing this until the user is satisfied. Some of the popular Agile methods include extreme programming, adaptive software development, lean development, rational unified process, feature-driven development, and dynamic systems development method, Scrum, and Crystal Clear. So Agile methods emphasize continuous improvement over going out and getting a complete set of user requirements initially. The major advantage of agile methods include fast development of application software. Some of the risks of agile methods are the analysis phase is limited or eliminated, increasing the risk of incompatibilities. And there's more emphasis on programming, resulting in less documentation, which may make it difficult or impossible to make later modifications. The manifesto for agile software development expresses these priorities: individuals and interactions over processes, working software over comprehensive documentation, and customer collaboration over contract negotiation. And finally, responding to change after requests are made instead of following a plan in a rigid manner. Agile methods aim to have light but sufficient development processes. User involvement is encouraged throughout the process. Modules are tested immediately after completion. Communication with users is informal. Extreme programming uses 2 programmers per module working on the same computer. It fosters constructive criticism and feedback. The Daimler-Chrysler payroll system was a large extreme programming project that failed. British Airways provides an agile success story. When do you use agile methods? You use it when a desired system is small, analysis is less important, and it requires a smaller investment of resources. You would use it for unstructured problems. It's often used for developing user interfaces. And it's used when users cannot specify all requirements at the start of a project. And that's because it may be a new domain and requirements may be difficult to conceptualize. It's also the case that the users may be unfamiliar with the technology. When not to use agile methods. Don't use agile methods when the desired system is large or complex. System failure entails great financial loss. The desired system must, and you also don't want to use agile methods when the desired system must interface with other systems. The SDLC is recommended for complex systems, and documentation is essential for integrating with other systems. And here we see a chart to decide using or not using agile methods. Outsourcing has become popular in recent years, and it's a formal business relationship to transfer internal business processes to a third party. Not all outsourcing initiatives are successful. The Union Bank of Switzerland Global Asset Management attempt in 2010 was an example of that. Several tools exist to help plan and manage a development project, including information systems projects. IBM's Rational Portfolio Manager helps plan investment in a new system and manage the development project and delivery of the product. Oracle's Primavera 6 provides integrated project portfolio (PPM) management software. Tools designed to accommodate the planning and management of any type of project include Clarizen, Project Insight, @Task, and Microsoft Project, the venerable project tool. Systems integration is where you have to integrate your new system with existing systems. And this is going to require an examination of the needs of the entire organization and planning to combine these disparate systems to allow data to flow between them. Integration is more challenging than development, and legacy systems may need to be interfaced with new systems. So here's some organizational initiatives requiring systems integration. Obviously, linking legacy systems and databases with enterprise applications or any type of new system, integrating media and social media into your existing intranets, sharing information systems and data among organizations and trading partners, as we've discussed in the past few lectures. Systems integrators must be skilled in hardware and software. It may be difficult to overcome hardware and software incompatibility issues between systems, so you need experts. Systems integration may span several organizations, requiring integration using telecommunications. So, in this lecture, we've talked about the systems development life cycle and its well-defined phases. How we have feasibility studies at each one of the phases to make go and no-go decisions as more and more information is obtained. We've looked at different notations, including data flow diagrams and unified modeling language, and how we implement by converting from the old system to the new using one of several strategies, and the need for training. We've also looked at support, which of course is going to be maintenance and also help. We also looked at agile methods and when they are appropriate and when they're not. They're really appropriate for small systems that are unstructured, but not appropriate for large and complex systems, especially systems that require systems integration, because they do not have the level of documentation often that is needed to do systems integration. Systems integration may be more complicated than the actual systems development. Thank you.